Welcome to Chemistry Corner. Coordination compounds, class 12. Why we want to read this kind of compounds? Because it is lot of uses. The coordination compound of iron is our hemoglobin. Same way chlorophyll. Without chlorophyll we can't get our food. Chlorophyll is a coordination compound of magnesium. Same way this side industry, when we see industrial process, gold and silver are most valuable metals. So in the extraction of these metals, coordination compound is very much helpful. So how this coordination compound differ from double salt? So double salt lost their identity in solution. It ionizes into all the ions. For example, potash alum. In potash alum, K2SO4, Al2SO4 thrice 24 water molecules. It ionizes into potassium ion, sulfate ion, aluminum ion. Whereas in coordination compound, it retain their identity in solution. For example, potassium ferrocyanate. So here we are able to get only potassium ion, that's all. The cyanide and ion won't come out of their coordination sphere. Coordination compounds also have a lot of various shapes. So here the scientist Werner has gave the theory for the coordination compounds. So here the valency has two different valencies for coordination compounds, primary valency and secondary valency. So primary valency is ionizable, which are satisfied by negative ion. Whereas secondary valency, it is non-ionizable, satisfied by neutral molecule or negative ions. So here that secondary valency, based on that secondary valency, the coordination number is arrived. And based on the coordination number, it has 3D spatial arrangements. So here we are going to take some cobalt compound. For example, 1 mole of cobalt trichloride and with 6 ammonia molecules, it gives 3 moles of AgCl on adding silver nitrate solution. So that means this compound gives 3 chloride ion in solution. That 3 chloride ion forms white precipitate, silver chloride precipitate. Only 3 moles of silver chloride we got. So 3 chloride ions are ionizable. That means that 3 chloride ion is present outside the square bracket. So the formula we get it CONH3 6 times Cl3 outside the square bracket. The next molecule, same way 1 mole of COCl3 5NH3. This compound on adding silver nitrate gives only 2 moles of AgCl. That means 2 Cl only ionizable. So one more Cl, there are 3 Cl. That means one more Cl is not ionizable. So it is present as secondary valency. So within the square bracket. So the formula for this compound will be CONH3 5 times Cl. Outside the square bracket Cl2. Next compound, 1 mole of COCl3 with 4 NH3 molecules. Now when we add silver nitrate to this compound, it gives only 1 mole of AgCl. That means only 1 Cl is outside the square bracket, that is ionizable valency. So the remaining chlorine, though 3 chlorines are there, 3 chloride ions we have to get, but here we are getting only 1 chloride ion as ionizable ion. The remaining ions are present as a secondary valency. They won't come out of the square bracket. That is coordination sphere. So the formula is CONH3 4 times Cl2 outside the square bracket, that is Cl. So ions which is present outside the square bracket are ionizable. So the square bracket is telling about coordination sphere. Whatever present inside the square bracket is called secondary valency. So here secondary valencies are non-ionizable, which is present inside the square bracket. That counts for the coordination number. So in the first case, that 6 ammonia is present inside the square bracket along with the cobalt. So here coordination number of cobalt is 6. In the second case also coordination number is 6 for the cobalt. But all the 6 are not by same ammonia ligand. Here 5 ammonias and 1 chloride is present. The third case also 4 plus 2. So there also 6 is the quadruple.